So now we're just going to go through them a little slower. All right. So here it says, right, if you're stating that alpha is true for every object X, and remember in our parsing, we build our parse tree, there are some things that represent terms, meaning they represent an object, like X is an object, f of X is an object, right? Alpha is not an object. It takes an object and returns true, false, right? So here is anything you want at all that represents an object, it's going to be true for, right? So if it's true for every X, then it's true for this object you plugged in, right? If you can say, hey, if it's true for every X, it's true for 5, it's true for Jeff's father, right? And so this just says syntactically, right? You parse your sentence and you see, yes, this returns an object, so we can plug it in, right? So now the other direction, as I've said already, right? You can do the for all for this X because it's a free variable, but you can't replace this with a for all, right? So it just says if you've proven that alpha of X is true without telling me any restrictions on X whatsoever, right? X is a free variable, then you can add the for all X, right? Everybody buying that? And now, how do you remove the X? Well, this says there exists an object. Well, if exists the object, in my proofs, when I was giving you proofs, remember I was drawing this line and saying, these are the things that we've proved already, and these are the things we need to prove, right? The things you proved already are kind of like we have the oracle to assure us that they're true. And if the oracle assures us that there exists an object X, then we can say to the oracle, hey, oracle, give us such an object, right? And then we give it a name. So this is a fixed object given to us by the oracle, right? It's not a free variable. You can't, for example, put a for all in front of it, right? Right, so it just says, right, let this denote the object that we know exists, right? And then this one is the more subtle rule, right? These things were called Golem functions, and it says here if I know this is true, I know X is a free variable, and no matter what value X has, this sentence is true. Well, which object Y exists might depend on my free variable, right? I'm saying this sentence, my oracle is assuring me that this is true no matter what X is. Well, the Y might depend on that X, right? So when you get rid of this exists Y, you have to remind ourselves that Y is a function of X, right? Does that make sense? And in George's proof system, he certainly doesn't do this, but he has this I'm within a subproof. So somehow you know it, and I've never quite ever figured it out. All right. This just says don't use the same name twice, right? If I say there exists an X, all right, let's call him Bob. And then I say there exists an X. Oh, it might be a different guy. So let's call him Jeff, right? And so sometimes you'll see we number things if we need new ones. And then adding the exists back in. Well, if you prove that alpha is true for some weird, crazy term, right? You prove this here, here's some weird, crazy term, then I can say there exists an object for which alpha is true, right? Right, so that's... Oh, here, there is an exception to it, right? Suppose that this is a line in your proof, right? You have X has a for all on it, and my term depends on that X, right? Well, now I can't replace this term X with an exists, right? Because there doesn't exist one object that works for every X, right? Every X could have a different object, right? People see that? Right? What does this say? This says for every X, right? Well, somewhat there is a Y, right? Because this gives from my X, it gives me some Y. So we want this to mean for every X there exists the Y. We don't want it to mean there exists the Y that works for every X, right? So you can't say there exists one Y, right? Because the Y is depending on the X, right? Everybody kind of follow that? So these are nuanced little rules, right? Oh, this is just the rules for negation. Everybody remember the rules for negation? You bring the negation out. Yes, you can. And the key is what you'll get is for all what are we saying is true? We're saying this is true, right? For every X, there is a Y. So can you go back to this? Yes, you can. All right. And that's probably what you started with, right? What we don't want you to write is that there exists a single Y that works for X, right? All of these nuanced rules is keep you don't want to go from this is a line of your proof to this is a line of your proof, right? So from this, right? That's the bottom line, right? And that's where, if you remember these rules, you can mechanically follow the rules. But if you're nuanced, if you get nervous about, well, what were the rules? Then you check again, right? This is telling me every X has a Y. And I know deep in my soul that that's different than there's one Y that works for every X, right? So keeping my intuition turned on helps me know that I'm applying the rules right. Especially since, maybe I start proving something and I haven't looked at the rules in 20 years. And then I think, oh, all right, well, what can I do? What can I do?
Professor?
Yeah.
Are you also able to conclude from that there exists an X, there exists a Y, because of the essentially the rule from removing there exists?
Yeah, certainly you can turn the for all into there exists an X, there exists the Y. Right? If every X works, then there is an X that works. And once you have that, you can go over to exists in X, exists to a Y exists in X, right? I mean, if I tell you that two things exist, it doesn't matter which order I say they exist, right? So you can, all of those rules work. Is that right?
Thank you.
Does that answer your question?
Yes.
Excellent. All right, so now this deduction one is subtle, right? And if I might have frightened you about it, let's think about it again, right? We're assuming, how do you do it? It's you start by assuming alpha of X, right? And now you kind of have to say to ourselves, for which X am I assuming it? And there's this really subtle thing is I'm not going to let you assume it's true for every X. I'm only going to let you assume it's true for one X, right? But which X am I going to let you assume it's true for? I don't care which X. You can give me any object and I'll assume it's true for that object, right? But I'm only assuming it's true for one object, right? You see the difference? It all comes back to the difference between these, right? So this is, you give me any fixed object and I'll assume it's true for it, right? And then we go through, and from that we can prove that beta is true for it. And then what can we conclude? We can conclude that if it's true for X, if alpha is true for X, then beta is true for X. Now, for which X, right? Right? Here we want to say, well, for any X, right? You give me any X, alpha gives me beta, right? So hence I can, right? So now it's a free variable and I can put the for all on the outside, right? Everybody kind of follow that? So similarly, if you have an axiom that has a free variable in it, now personally, I'm not sure I'd ever want to have axioms that have free variables in it, but here's an example of an axiom that has a free variable, right? I say you X plus Y equals Y plus X, right? That's an axiom with free variables, right? If I were going to give you this axiom, I would make them not free, right? But there's the same subtlety about right? All right. So don't worry too much about this, right? We'll give more examples later about where it goes wrong, right? Where we need to be subtle about.